Hi, my name is Alex, and I'm going to go over some information about how I go about derivations in this class. So basically, when we are doing derivations truth functional logic, there's three basic types. We have a direct derivation. In a direct derivation, there will be no assumptions. We can use a direct derivation when we get to the conclusion of our show line without any assumptions, no assumptions. If we're using double negation, introduction, and elimination, and modus ponens and modus tollens. This doesn't mean if there's like a nested derivation that has an assumption, that's okay, as long as that assumption stays within that nested derivation. The derivations that do use assumptions are the indirect derivation and the conditional derivation. The type of assumption that you'll be assuming is going to be relevant to the type that you are doing. So when we're doing an indirect derivation, we're going to assume the opposite of the show line, and what we're trying to do is find a contradiction. So we're going to when we're doing an inductive derivation, we're going to just be trying to show the opposite. So show P, therefore Q. We're going to show then in that, we're going to show this line. That is going to be our assumption, because this is the opposite. Let's say we're showing not P, therefore Q, then our assumption would be P, therefore Q. The reason why we don't add a negation to get the opposite of something, I'm not really sure about that. I don't have a good answer to it. But that's the way I've gotten Carnap to work. So never add a negation. You can only subtract one. So this is okay, but this is not, even though they mean the same thing. So that's the indirect derivation. The other type is a conditional derivation. This is an if-then sentence, and so that's going to be something like we have a variable, therefore a variable. When we're doing a conditional derivation, we're going to assume the antecedent, that's this side on the left, and we're going to be proving the consequent. So we are going to, when I do a conditional derivation, the first thing I do is I type in the assumption. Then if I need any premises, I'm going to add the premises, but I usually add the premises whenever I need them. I know that I'm trying to find Q, so I put Q there. I don't know how I'm going to get Q, and then I'm going to write the type of derivation I'm going to be doing at the end, just so I know where I'm going with this derivation. So I could have as many nested derivations as I need, but I know if I follow this line right here, that this show line is connected to this derivation. This is what I'm trying to prove, and this is how I'm proving it, and this is the assumption that I've made. Yeah. But basically, so we are turning this line vertical. We are putting P there, and then we're putting the consequent there. We have it vertical, we have P, therefore Q, P, therefore Q, and then when we're doing the derivation, we're just going to fill in the gaps. So let's say that Q is a premise, and that is actually our derivation. We don't need to prove anything else. This is the material conditional. And we have proved that from having Q as a premise that P therefore Q. So this is how the conditional works. We can also do the other conditional where we have not of the consequent. So we're going to assume P. We are going to, we also have not P as a premise, but we're trying to get to Q. So Q, we don't know how we're going to get there, but we know this is our conclusion. Interestingly, we know that we have P as our assumption, and then we have not P. We know that this is a contradiction, but how are we going to use this? We can use this by doing a indirect derivation. That's what we do when there is a contradiction. So we're just going to show not Q. And then, so not Q is going to be our assumption, because we can only remove one negation. And let's see if this works. Indirect derivation of lines 2 and 3. It did work. Awesome. And then we can just use double negation elimination of line 4. And now we have our antecedent and we have our consequent. We have all valid assumptions. The assumptions match the derivation that we're trying to prove. Let's see if this one works. And there we go. We have the other material conditional. Anyway, I hope this has helped some of you. If you think this has helped, I could make some more videos explaining the other rules that we've built in this class, or just anything else that I think that would be helpful. I thought that kind of explaining the types of derivations and the assumptions, like the assumptions have to match the derivation, would be useful. Because you can't assume anything. You can't make something up. The types of assumptions you're making have to be part of the type of derivation you're doing.